Okay, this is a Zenith Trans Oceanic AM/FM multiband, Royal 3000-1. This radio was made on or about 1965, plus or minus maybe a couple of years. It is solid state. There are no tubes in it. It has 12 transistors in it and a handful of diodes, I think like half a dozen or something in it. Obviously receives FM and AM, not stereo FM. It also has 7 shortwave bands that it can receive. I forget what the exact coverage is. Long wave through the higher frequency stuff. I think up to 18 megahertz or something. Don't have to check. Doesn't matter. When I got this radio, about 10 years ago, it did work on the AM broadcast and all of the shortwave bands. Well, it worked well. The FM band, if I recall correctly, did not work. Not something I'd particularly worry about because I have a gazillion FM radios. If I need to hear that, that's where I'd go. I like this one because it's shortwave. And I want the AM broadcast band to work as well, of course. It did work. About a year ago, thereabouts, I went to use it, and it worked for about a few seconds. And I could hear reception, and then faded out to nothing but noise. I played with it a little bit, thought maybe okay, the wafer switch is dirty, the band select switch was dirty. Tried to wipe that clean. I did not put any sprays in it. I do not do that unless I absolutely have to. Nothing seemed to work. Although it did have an audio output. Noise. I'll show a little bit more about that a little bit later. But there it is. It's not in the best shape. It's got a lot of grime on it. I've never cleaned the thing. I've used it for all those years, and it worked just fine the way it is, so I've just left well enough alone. Unfortunately, the previous owner, actually the original owner, who I've met, rest in peace, Al, I got it in an estate sale by his caretaker, who happens to be a family member, so I know the provenance of this radio. And he was pretty diligent about replacing the batteries. He always wrote down on the right on the battery pack, I'll show later, the dates that he replaced the batteries. Now this thing's designed to run on, it has 8 D-size cells. And back when this was made, those would have been, in fact that's what's specified for this radio, they would have been carbon zinc batteries, not like the alkalines we use today. Unfortunately, the last, or somewhere near the last batteries he had in it, he left them in too long, and they leaked and did cause some damage, although from what I can tell it's mostly cosmetic damage inside. I've seen worse and managed to get them to work. I've restored a lot of radios. I've never restored this particular model, although I have worked on transoceanics. Some of them had vacuum tubes in them. At least one was solid state, and if I'm not mistaken, it was a 7000 series. But I really do want to get this up and running again. I'll start another clip here so I can splice it in, showing what's going on with it, what the symptoms are right now. I have a pretty good idea what the problems with it are, which of course we'll get into later. and have a look under the hood. So yeah, let's swing his boy around. There's the front of it. Yep, focus looks alright. And these things, this thing is heavy. They call this portable. Yeah, it's got a handle on it, which happens to be the telescopic antenna hid in there. That's pretty cool. Lord knows if this breaks while you're carrying it and this crashes to the ground, ouch. Although it is pretty rugged. I can't believe how much this thing weighs. This has no batteries in it. Imagine this thing weighed down with 8 alkaline D cells. That'd be an arm stretcher. So, if you're not familiar, there's a button you push up here that lowers this down. And you can see the dial. And then you pull this out, and you've got access to the controls. Not much to it. It's a tuning dial, tone control, on-off switch and volume. There's a phone jack, so you plug in a headphone to it. Looks like a 1/4 inch standard phone jack. It's got a dial light in it that does work, and a switch here that switches it from plain FM to FM automatic frequency control. Get into that later. As I said, when I got this, everything worked except the FM, and even that, there was noise suggesting that there were, the circuits leading up to that section were working just fine. It does have the best reception table. Of course, this is way out of dated. Some of these may be accurate, but I think for the most part they're defunct. You can see the original owner had made some notes, so he was using this thing. There's some more notes he made. Interesting. It's got the call sign. FM. Yep. Interesting. So that's there, and I was able to find easily a service manual for this. It goes through. It has all the schematics. It also has alignment information. Where to go, where all the components are that you need to turn to do an alignment. I've never twisted any of the controls in the back because it always worked so well. And like I said, the FM, that didn't bother me, even though I have a pretty good idea why the FM section's not working. Again, later. So this is it. Now, how to get this thing apart to service it. It's not difficult. If nothing else, these guys, Zenith, they had service in mind. It's obvious when you get into the thing. Number one, the transistors in this, every single one of them, it has 12. Every single one of them is socketed, so you need not solder on them. And I know back in those days it was a big concern about excessive heat on the leads of transistors causing damage. Well, back in those days they weren't using so much pencil irons with 25 watts. They were using these 300-watt guns. Yeah, you put 1500 degrees on the lead of a transistor, it's not going to go well. But the 700 or 800 degree pencil iron, not a problem. Anyway, the transistors are socketed, which is convenient for testing and troubleshooting. It's also good for replacement. But from my experience and everything I've read about this particular model is that the transistors are rarely the trouble. And if they are, it would be the output ones that tend to have quite a bit more milliamperes of collector current flowing through them. But even that's not crazy high. The audio output on this thing is what was it? About 500 milliwatts, a half a watt. I think the speaker in here, it is oval. I think it's 4x5, thereabouts. And when these are working right, man, they sound really great. It's with the heavy chassis and the nice baffling that it provides. You get a pretty decent sound out of it. Not real bassy, but you wouldn't want that, or wear your batteries down for no good reason. So that's it. I've already removed the screws that secure the chassis in. I've had the chassis out just a little while ago. I gave it a look over and was studying the schematic drawing, trying to find out where I needed to get and what components needed to be looked at. And so all of the mounting screws, all 4 of them, have been removed. But there are some things that you need to know to be able to get the chassis out. Figure I'd go over that just in case anybody else is working on one of these things. Obviously, you need to pull the knobs. These knobs are pretty well made. These are in excellent shape on this radio. Not hard to pull it off. They're not just plastic. They have the springy steel clamp on there to keep everything tight, those are great. Volume control on-off switch, same deal. These don't have pointers on them, so they can go in any position. This one doesn't have a pointer on it either, but it is keyed with a flat. Probably because it provides, you can get a bit more torque out of these than with these. Now these both have the metal spring steel on them. Very good idea. And they popped off real easy. So that's all you need to do with the front panel to get the chassis out. Next, let's look at the back. Let's put him here. Yeah, that'll work. Let's open this up. Oh, daggone it. Hello? Yeah. Hey. Oh, daggone it. I forgot about that. Okay. You guys are out of there before 6, aren't you? 6 o'clock. Well, I got no way to get down there right now, but I can drop by tomorrow, I think. Wait a minute. Oh no, can I leave it in an envelope and put it in the door slot for you tonight? Ah, okay, cool. Okie doke. You bet. Bye. Sorry, my mechanic. Okay, where were we? Open the back. And, you can see it pretty well, I guess. First thing, I'm talking about the guy left the batteries in it and they leaked. This is the battery box. And you can see all over here, he's got dates and things. The earliest date I see is here, which looks like July 73. As I said, this thing was made about 65. Who knows how many batteries he'd had gone through it before 73. I'd hope more than one set. Let's see, here's 86, 92, 88. Here's one he got scratched out for some reason. I can't quite read that. But the guy did keep track of how old the batteries were in it, which is always a good idea. So to get this thing out, obviously you take the knobs off, done that. This battery pack, this battery case, this holds 8 D cells, which they thing lasts 300 hours if they're carbon zinc. I just don't know about that. This disconnects very easily. I'll set this aside. I don't need to show you the inside of this. It's not great. It's not horrible. It could be reused, but I've really no interest in that as it is. I have the original Zenith adapter that was a extra you could buy. From what I've read, you didn't come with the radio. You had to buy that separately. And here it is. Zenith transistor radio AC converter power. Oh yeah, I guess part number S-60 or 65074. Power supply input 115 or 230 volts, which is switch selectable. 1.5 watts. 60 milliamp DC output. Use only on 12 volt DC receiver. And it's nifty. It's not a wall wart exactly. It's just a steel box, presumably a transformer and some rectifiers in there. So it's your line cord input and your output. And this oddball connector. Looks like a sub mini, 1/8 inch, except it's got this real long insulator. Normally, you know, it's just a little ring toward the top. But this one's not like that. I've never seen this before. Odd. It does work. This power supply is what I've been using for this since I've got it. This is plugged in. There's no warmth at all with it. There's the voltage select switch for the primary, 115 or 230. Of course, it's got a locking screw so you don't accidentally trip that. Yeah, neat. So, to get this out, obviously you pull the battery pack away. You need to remove some connectors. These two from the speaker. These just pull off. How convenient. Do be careful. These might be a little sticky on there, and you don't want to break the terminal of the speaker when you pull these off. So just kind of work them to get them off. Now I've got these stuck on here just a little tight because I want to do a functional test before I start taking the chassis out. The 4 screws that you need to loosen to get it out. 2 are at the bottom. There's one there, and there's one under here. Not hard to spot. They are screwed into Tinnerman nuts, so they look like something that would screw into plastic or wood. You know, of course, threaded sort of things. They're hex heads. They also have a slot, so you could use a regular straight screwdriver, flat screwdriver to get them out. I tend to use the nut driver. It's easier to keep from slipping. Another screw is right up here. That's a machine screw, number 632 machine screw. It's actually screwed into a metal stud. Looks like steel, tapped steel standoff in there, which is nice. So there's one there that you need to take off, and there's one little bit buried in here. This needs to come off too. This is the connection for the antenna, this one here. They call it the wave magnets. It's just a loop stick antenna. It's for the low band and the AM, the broadcast band, primarily. So that needs to come out, and when you do, you can move the wiring out of the way, and you get right down in here. There's another hex head, 1/4 inch hex head screw, also with a slot in it. That's a little tricky to get to, but you can get to it once you move this out of the way. The wave magnet antenna loop stick plug. I'm going to plug that back in because we're going to do a functional test. Now it's interesting. This is a format of a miniature tube 7-pin with a standard 7-pin tube socket. Kind of cool. The loop stick antenna actually has 3 windings on it, which makes sense. 1, 2, 3, 4, 5 wires, and there's a center tap, so you get the idea. So just kind of move that out of the way. So the chassis is just kind of sitting in here right now. The only thing holding it is gravity and the knobs. Okay, what else? Let's see. Up here, you need to undo this if you want to pull the chassis. This green wire that goes to this terminal, which is strangely not marked. This green wire simply attaches to the telescoping antenna here. So, you need to mind that. So you pull the speaker connections off, you pull the loop stick antenna connector off, you undo this whip antenna connection for the FM and some of the shortwave. You'll need to get the band selector switch off. See if it's showing. Yeah. This here. It's once you get the back open, there's a set screw for this. It also is a 1/4-inch hex head, and it has a slot in it for standard flat. So you need to undo that set screw, and then this just pulls out. But you will need to take that off. It's loose right now. It's just kind of stuck in there. Okay. What else? Oh. That thing is heavy. Here is the input for the external adapter power supply. That needs to come off too. Easy enough to do. Let's see. It's 9/32, and I've already loosed this, so I don't need a handle for this spinner. But yeah, just pull that out. Now there's a nut and a washer. Be mindful of the washer. Don't want to lose that. And make a note that it's on the outside, not the inside. Alright. Now, looking in here, you might be able to see some corrosion, particularly down in the bottom. Some in here, well, dust anyway, dirt. There's some up in here around the volume control on the chassis. It looks like, to me, everything that's zinc plated on the chassis and some of these coils and the back of this pot is got some surface corrosion on it. I am not going to clean that. It's stable. It's not changed since I've had it in 10 years, thereabouts. My first thought was, yeah, the corrosion got to the connections for the transistors. That doesn't seem to be the case. I've played with that a little bit. I haven't gotten here and probed anything with a scope meter or nothing like that. Just a pencil and maybe because these are all socketed, that's the first place you look. Make sure that corrosion hasn't opened a connection or bridged one. Said the thing has 12 transistors in it. A whole crap load of trimmers. The transistors are, let's see, in this there's one is the oscillator. I don't know which off the top of my head right now. One is the oscillator, one is the mixer, I'm pretty sure. Or is no, I'm sorry. RF amp, mixer, and oscillator all in one circuit. For the AM bands, RF transistor, RF amp, oscillator, and mixer coils. First IF, second IF, third IF. For the AM, it's first, second, and third IF coils. For the FM, it's I think first would be in here. Nevertheless, IF for the FM is here, and in here, in this box, isn't a coil at all. That's the discriminator circuit. A couple of matched diodes, I think some capacitors, maybe a resistor or two inside that. I'm hoping that's not a problem. I do not want to have to get into that. Let's see, what else we got? The first audio frequency amplifier, the second audio frequency amplifier up under here, a couple of transistors. This one they call the driver, which is correct. This guy drives the primary of this transformer. The secondary of this transformer is center tapped, and that drives this push-pull Class B stage of audio output. Those two drive this center tapped primary transformer. The secondary of this goes right to the speaker, which I read is 3.2 ohm. Given how simple the audio circuit, like I said, I've studied the schematic. Given how simple this circuit is, it's amazing. The performance of it is remarkable. These two audio output transistors are indeed need to be matched. You see both of these have a letter. I don't know if it's focused well enough, but each has a letter H printed on the top to show that they're matched. It's matched for curves. It's important for low distortion and so forth. Let's see what else. All of these, each one of these trimmers, for the most part, there are other patterns and things in here, but each one is for a separate band. Most especially with what's going on down in here, the AM bands, the shortwave and the AM broadcast. But what's really cool about this is that each band has its own coils, and you're only seeing half of them. The other half are on the other side of the chassis, which we'll show later. But in some radios, I guess to control expenses, the band select switch just added the coils together in series to get the right resonance, the right frequency of resonance. This doesn't, from what I've seen on the front end of this, and I've not studied it hard, but at a cursory glance, it appears that it actually selects a separate coil independent of all the others for each band. Well, that's a wonderful thing, because there's not so much interaction as you're trying to tune this thing up. You know, each one of these coils has a slug in it that needs to be tuned, and these things are delicate, and you don't want to have to, with the series strung coils, you tune one, you got to tune all the others, and you have to go back and forth and back and forth and back and forth. Before you know it, you've worn them out and you crack the slug. You do that, coil done, unless you got a new slug for it. These things, they're made of usually powdered iron or ferrite material. They can be quite fragile, especially in an older radio where the slug is kind of stuck in, the slugs are threaded, and you can turn them, and they're like screws, and that's how you tune the coils. But over the ages, these coil forms, they shrink and they clamp down on the slugs, and if you try to turn that slug, chances are, if you're not really careful, you're going to crack the slug, and once you do that, the slug needs to be replaced. Don't do it if you don't have to. There really shouldn't be any need to. These are trimmed, these are adjusted at the factory where they need to be. Unless there's a serious problem with the coil anyway, you should not need to move these. That's why they give you all these wonderful compression trimmers. These are mica, ceramic and mica compression trimmers. Very reliable. They are open to the air, and mica does absorb moisture some, and some of these have some surface corrosion from the battery leakage. I don't know if that's a problem or not. We'll see about turning any of those later. I will avoid that at all costs if the thing works well enough. because that can cause other problems. So what to do? Let's before I pull the chassis out, do a quick function test so you can kind of see what the thing's doing. Let's open this up. Put the knobs back on. There we are. And the volume knob and the tone knob. This is on. And turn it off. Plug it in. I've checked the output of that power supply. It was about 12. Oh, damn it!
Call from 9792452.
Off with you. I'm sorry. Knobs are back on. I'm going to unplug the phone. Damn it. Email me. Okay. The power supply is on. I checked it. It is 12.3 volts, which is just fine for a 12-volt radio. I could probably go up to 15, 16 volts on this without any grief. I wouldn't do that unless I had to, but actually, and the thing will probably work down to 9. You know, they do take into account battery wear, especially with dry cells. So turn it on, turn it up, and there's some noise. Right now, the band switch is set to the AM broadcast band, and here, I mean, where I am, we've got pretty strong signals there. So turn it up all the way. Normal noise, but nothing. Not a thing. It's like there's no tuner there. The same with all of the other shortwave bands. Here's long wave, nothing. Broadcast, whether it's 2 to 4 megahertz, 4 to 9 megahertz a seat, nothing. 9.4 to 10.1 megahertz, nothing. Right? Nothing nowhere. It's interesting when you switch from the AM bands to the FM band, FM broadcast band, you do hear a change in the tone because it's connecting to the discriminator circuit, which is only for the FM, and the detector circuit, which is only for all the AM shortwave bands. That's the FM. Notice the difference? That's a clue. The other thing, the tone control does work. And I know, turn this off. I know where the tone control is in the circuit, and it's pretty far along. It's actually, let's see, it's between the first audio amp and the driver transistors. That tells me the audio amp in this thing's working just fine, as well as the driver. It even suggests that the first audio amp circuit's working. It seems to me the problem is somewhere in the IF strip, or there is an electrolytic coupling cap that couples all the audio into the audio output section that has dried up and gone open. Without that, if that opens up, you just get no audio. If that shorts, you usually get very quiet and heat. So my thinking is that this just needs to be recapped. Some of the smaller low voltage, all of it's low voltage, electrolytics in this thing gone out of spec to the point where the thing just won't work anymore, and so I'm going to replace some of them. Maybe not all of them. Those that I can test in circuit, I'll do so, and you know, make a call on whether they can stay in there or not. I tend to want to leave the originals in, except for certain circumstances where it's critical. The place in the circuit is its value, and low leakage things are crucial to proper operation. I'll replace those, sometimes without even testing them. I always, after I remove any capacitor and replace it, I always keep the old ones with just enough lead length on them so that I can test them to find out if that capacitor really was bad, so I get a better idea of where to look next time if I run across this model again, or any other radio or device for that matter. So I'm gonna pull the knobs off, pull the chassis out, and go from there. That'll be part 2, and I'm going to string these together.